Every year, hundreds of massive ships, some stretching nearly 1,000 feet long and weighing over 40,000 tons, begin the final voyage of their lives. But instead of sailing into ports with honor, they are driven straight onto the muddy beaches of South Asia. Waiting there are thousands of workers armed with nothing more than 5,400 Fahrenheit cutting torches and earning less than $4 a day. These floating cities, once vital to global trade, are slowly torn apart, steel plate by steel plate, compartment by compartment, until they disappear as if they never existed. Over 90% of a ship's materials are recycled, but at a devastating human cost. Join Mana Tech Explorer as we explore the shipbreaking industry, the dismantling of colossal structures, and the workers risking their lives to give steel a second birth. To understand why massive ships must eventually be scrapped, we first need to examine the full life cycle of the modern maritime shipping industry. Today, the global commercial fleet consists of more than 100,000 vessels. Each year, around 2,700 new ships are built and launched, while 400 to 500 aging vessels are permanently retired. Most ships operate efficiently for only 25 to 30 years. Beyond that point, maintenance costs rise sharply as saltwater corrosion weakens the steel hull. Cargo holds, machinery systems, engines, and even the overall structure can no longer meet original safety standards. Stricter global emission regulations, including sulfur limits on fuel, also render many older ships legally obsolete. In addition, accidents such as collisions, groundings, fires, or severe mechanical failures can abruptly end a ship's service. When repair costs exceed operational value, dismantling becomes the only viable option. And a crucial question emerges. Where do these massive ships go when their service finally ends? Are they dismantled at sea through complex salvage operations involving cranes, robots, and structural simulations, or are they simply towed onto land? The reality is far more direct. Most end-of-life vessels are driven straight toward the beaches of South Asia, where labor costs are low, coastlines are wide, and demand for scrap steel is immense. Their final destination is usually one of the world's 3 most notorious shipbreaking hubs: Ulung in India, Chittagong in Bangladesh, or Gadani in Pakistan. Together, these sites handle nearly 70% of all global shipbreaking activity. In Ulung, hundreds of vessels are beached each year along a 6-mile shoreline, forming a vast open-air dismantling assembly line. Chittagong relies on powerful tides to force ships onto muddy shores, while Gadani, once the fastest shipbreaking center in the world, earned its reputation at enormous human risk. Despite differences in scale and technique, all 3 share the same purpose: dismantling tens of thousands of tons of steel and feeding it back into the global economy. Before a ship can be dismantled, it must first be carefully valued. Buyers, typically scrap steel traders or shipbreaking companies, assess each vessel based on 2 primary factors: the amount of recoverable steel and the current market price of scrap metal. A standard cargo ship can generate between $3 and $6 million, while cruise ships are often worth significantly more due to their large quantities of non-ferrous metals, stainless steel, and high-value interior equipment. Ship dismantling generally serves 2 purposes: breaking vessels down for raw materials and salvaging components for reuse. Most steel, copper, aluminum, electrical cables, propellers, shafts, and machinery systems are recovered. At the same time, valuable components such as engines, navigation systems, hydraulic pumps, and generators are carefully removed, inspected, and resold to smaller vessels or local markets. By the time cutting begins, the ship has already fulfilled its final economic role, becoming a vital source of materials and reusable parts for multiple industries. After the final inspection and completion of all sale paperwork, the ship begins the last journey of its life. No longer able to move under its own power, it is guided by a team of tugboats toward the scrapping yard. The most critical moment occurs during high tide, when rising seawater lifts the massive hull, giving the tugboats enough control over direction and thrust to slide the vessel onto the sandy beach. Miscalculations can leave the ship stranded offshore or drifting off course, complicating the entire operation. But when everything aligns perfectly, the ship glides onto the shore under its own momentum and comes to rest as the tide recedes. The hull, hidden beneath the water for decades, is fully exposed, marking the transformation from a seafaring vessel into a colossal mass of material, poised to be dismantled in the months that follow. Hundreds of workers move through every steel compartment, dismantling the ship from the inside out. The first stage is to completely clear the vessel's interiors. Doors, tables, chairs, lights, stainless steel railings, decorative panels, electrical wiring, and ventilation systems are all carefully removed. Each item is inspected to determine whether it can be reused or resold, especially on cruise ships. This process becomes far more complex in areas such as theaters, cinemas, gyms, swimming pools, bars, and the hundreds of cabins, which must all be stripped manually. High-value components, including industrial kitchens, sound systems, and air conditioning units, are carefully extracted intact and sold to local markets. Once the interior has been cleared, the environmental handling team steps in, pumping out residual oil from tanks, treating sludge, wastewater, and any chemicals, ensuring hazardous materials are safely managed before the steel dismantling begins. The removal of residual oil, chemicals, and gases from pipelines and tanks is a critical step. Any remaining flammable substance could ignite under the flame of a cutting torch. Once fully cleared, the ship is reduced to an empty steel framework, ready for the heaviest stage, cutting the hull. This is the core task of the entire process. Workers erect scaffolding, mark precise cutting lines, and wield oxyacetylene torches exceeding 3,000 degrees Celsius to pierce steel plates nearly 3 centimeters thick. Each completed cut separates a section weighing several tons, carefully rigged with cables before being dropped onto the sand. The thunderous clang of steel hitting the beach signals another piece of the ship's body severed. Tractors then drag these massive sections deeper into the yard to be further cut into smaller pieces. Steel cutters, transport crews, and cable recovery teams work continuously, and depending on the ship size, this stage can last several months to over a year, recovering as much material as possible. Although the shipbreaking process may seem methodical, the reality is far more dangerous. Workers often labor 12 to 16 hours a day for only $3 to $4, constantly exposed to falling steel, slips from heights, explosions from residual oil, and inhalation of asbestos dust, a substance that can cause permanent lung damage. Protective equipment is scarce, and access to medical care is limited. Since the late 1960s, nearly 2,000 serious accidents have been recorded, though the actual number is likely much higher, as many migrant workers remain undocumented. Despite efforts by international organizations to improve conditions, change has been slow. Shipbreaking relies heavily on human labor rather than machinery, keeping the risk ever present. Outside the yards, workers often live in makeshift housing without clean water or sanitation. The physically demanding, unstable nature of the work restricts education, insurance, and alternative livelihoods, forcing many to remain tied to this dangerous occupation for years. What has allowed the shipbreaking industry to thrive for more than half a century is the enormous economic value of recycled steel. When a vessel is dismantled piece by piece, every steel plate, pipe, and structural frame becomes a resource. A medium-sized cargo ship can yield 10,000 to 25,000 tons of steel, while a large cruise ship can exceed 40,000 tons. All of this steel is sent to furnaces to be reborn as billets, rebar, plates, and countless products used in construction, bridges, roads, and infrastructure. The environmental benefits are equally significant. Recycling steel saves up to 70% of the energy required to produce it from ore and reduces CO2 emissions. Beyond steel, other metals, copper from wiring, aluminum from railings, brass from propellers, and stainless steel from kitchens are recovered at high rates. Mechanical components such as compressors, generators, pumps, and navigation systems are inspected and resold. From a ship that seems destined for scrap, the industry generates millions of dollars in materials and equipment, giving these vessels a second life in new projects. Shipbreaking is often hailed as a triumph of recycling in the circular economy. Steel is recovered, resources are conserved, and global emissions are reduced. Yet, the environment does not always benefit. At shipbreaking yards, the cost is measured not just in numbers but in soil, water, air, and human lives. A single ship contains dozens of hazardous substances. Asbestos in pipes, lead-based paint on the hull, PCBs in electronics, heavy metals, residual oil in tanks, and even biological waste from cruise ship sanitation systems. If mishandled, these toxins seep into the soil or wash into the sea, causing contamination that can last decades.
Around many shipbreaking sites, heavy metal concentrations far exceed safe limits, fish and marine life decline, and the land degrades. The beaching method, while cheap and widely used, amplifies environmental harm by exposing open beaches to hazardous waste without proper treatment systems. Because of the environmental hazards and safety risks, not every ship can be driven onto a beach for dismantling. Certain vessels require special handling under strict controls. Nuclear submarines are a prime example, containing reactors, fuel rods, and radioactive cooling systems, all extremely dangerous if dismantled improperly. Only the United States, Russia, and the United Kingdom currently have the capacity to safely dismantle these vessels, a process that can take 10 to 15 years per submarine. In response to such risks, the world has begun implementing stricter regulations. The 2009 Hong Kong Convention mandates that ship recycling be carried out safely and in an environmentally sound manner, though it will not officially take effect until 2025. Additionally, the European Union requires ships flying its flag be dismantled only at approved facilities, ensuring higher standards of safety and environmental protection. Every ship carries a fragment of the ocean's memory, years spent crossing waves, transporting goods, and carrying people to places they had never seen. But when that journey ends, the steel does not vanish. On ship-breaking beaches across South Asia, hundreds of workers labor day and night, cutting apart massive steel plates and returning materials to the world, steel that will go on to form bridges, factories, industrial zones, and sometimes even new ships. This life cycle, though fraught with danger and controversy, remains a vital link in the global economy. It reminds us that the end of a machine is not a loss, but the beginning of another form, stronger, quieter, and enduring. To discover more engineering stories behind the world's great structures, like and subscribe to Maritime Explorer so you won't miss the journeys ahead.